So say we have an equation like the one written up on the screen. F of x equals x cubed minus 7x squared minus 28x minus 20. Right, so based off of our knowledge of polynomials so far, you can tell me that it's a cubic polynomial, right? So some things that we know, right? It's cubic. It has a positive leading coefficient. So that means on the right-hand side of the graph, right, we're facing up, and on the left side, we're going to be facing down because it's going to be opposite, right? We can talk about the end behavior. But one thing that we're very interested to know in, right, and that we do a lot in algebra class is we're asked to solve for the x-intercepts, to find the zeros of the function, right? Those are the same thing, right? Most of the time in algebra, we give you an equation, we ask you to solve this. So the only way that we know to solve this equation right now, so I'm just going to copy it down so we can set up an equation, maybe not. Right? So the only way that we know how to solve this right now is with grouping, right? There's 4 terms, so in theory, we should be able to factor it by grouping. So we know that, okay, we could cut it in half, and then if we take out the GCF of both sides, I can divide this side by x squared, so we're left with x minus 7, and then the right side I can divide by negative 4, and I'm left with 7x minus plus 5, and then right? These two groups aren't the same, which means that either I took out the wrong GCFs, which I didn't, I can't take out anything else from them, or that grouping doesn't work, right? So the grouping method fails here. So then the big question you might have is, well, how the heck am I supposed to solve it then? Well, that's when there's some other theorems in math that come into play, and that's what we're going to be learning about and covering today. So one thing that can kind of help you get started, and this is going to be a multi-step process. So this video is just going to look at the first part of figuring out what the possible solutions are. So we're going to be learning about something called the rational root theorem. So the rational root theorem is helpful, especially think back in the days before there were calculators, or especially before there were graphing calculators, so you couldn't just look at a picture of a graph, right? If you had to solve it like by hand, right? The rational root theorem is something that gives us a list, right? It gives us a list. There we go. It gives us a list of all of the possible rational roots of a function. I abbreviate those as PRRs for possible rational roots. Right, so just as a reminder, what does rational mean, right? A rational number is a whole number or a fraction. So what the rational root theorem will do for us is it allows us to create a list of all of the possible whole number or fraction solutions to the problem. So it gives us a list of possibilities. So if you think about the x-axis, right, there's an infinite number of whole numbers and there's an infinite number of fractions along the x-axis. So what this does is it narrows it down to a much more manageable list of things for us to check with. So all we're going to do in this first video is talk about how to create this list. So what the rational root theorem actually says. So I don't know what the formal language of it is. I'm going to write it kind of more in plain old English, like this is kind of what it means. So if a number, we'll call it, hang on, let's start over. If x equaling c is a root of the polynomial, which means that c is one of the x-intercepts of the function, or f of c is equal to 0. Then C is the quotient of a factor of the constant divided by a factor of the leading coefficient of the polynomial. Okay, so that seems really, really confusing, and like, how am I supposed to know what that means? So, what that's going to do is we're just going to talk about that kind of in a basic formula setup, and then we're going to go back to that function we started with and just make a list of all of the possible rational roots. So our possible rational roots, so our PRRs, are equal to plus and minus. Right, so it can be a positive or a negative value. And then I call these P's over Q's. So P is a factor of the constant. And then C is a factor of the leading coefficient. Oh my goodness, my pen does not want to work. So let's look at an example to kind of make sense of how this works. So to start thinking about how to solve our initial function, we're going to find the possible rational roots for the function above. F of x equals x cubed minus 7x squared minus 28x minus 20. So the first thing we want to do, I don't know why I wrote a C here. That should be a Q. Whew, end of the day. So we want to identify our P's and our Q's. So I don't know why we use those letters for this, but every textbook I've ever read has those in, and every teacher I've ever talked to refers to it like that. So P is the constant term. The constant term is the number in the function that has no variable with it. So this is going to be my P. So the first thing I'm going to do is write P is equal to 20. And then I'm going to list all of the factors of 20. So my factors of 20 are, I could do 1 and 20. I could do 2 and 10, and 4 and 5. I like to list mine in numeric order. You don't have to. It's just the way my brain works, and I like when things are organized from least to greatest, and I find that it helps me organize things and not miss answers. And then Q is our leading coefficient. So your leading coefficient is the number in front of your highest variable degree. So our highest exponent here is a 3, so the number in front of x cubed is 1. So my Q value is 1, and then just like with the 20, I'm going to list all of the factors of 1. And this is super easy because it's 1. So all we're going to do to find our possible rational roots, our PRRs, is going to be equal to plus and minus I'm just going to set this up so I can easily do it. So I'm going to take every P number and put it over every Q number. So the first P number I have is a 1, so I'm going to put 1 over my only Q number, which is 1. And then I'm going to do plus and minus. Okay, the next, so I'm done with the 1. So now I'm going to do the 2. I'm going to put 2 over 1. Right, so now I'm going to do the next number, 4 over 1. So you can probably see where this is heading. Right, and then we just keep it going. right? So I'm just going to put the next p number, which is a 5, over my only q number, which is a 1, and then we're just going to keep going. So I need to do the 5, the 10, and the 20. So I'm just going to cheat and copy them all in now. And I know 1's going to be in the bottom of all of them, and then I'm just going to put 5, 10, and 20. And then I just want to simplify. So my PRRs are going to equal plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 5, plus and minus 10, and plus and minus 20. And I just realized I wrote the 5 twice. My bad. So what that means is that the only possible solutions that are real numbers, so a whole number or a fractions, are positive or negative 1, positive or negative 2, and so on. That does not mean that they all are, right? This is a maximum of 3 solutions, so they can't all be, but these are the list of possibilities that we can start with. So we're going to do one more together. Right, so find the possible rational roots, PRRs, of f of x equals 2x cubed minus 5x squared minus 10x minus 8. If you want to pause the video and try this by yourself, feel free. Otherwise, I'm just going to go through and explain it. So again, you want to find your constant term first, so that's going to be an 8. So my p is 8, and all of the factors of 8 are 1, 2, 4, and 8. And then my leading coefficient, my q value, is 2. And all of my factors of q are 1 and 2. So for my possible rational roots, I'm going to get plus and minus, and then I'm going to do each p number over each q number. So the way I kind of like to think about this is I have 2 q numbers. So for each q number, right, so for each p value, I'm going to get 2 fractions. So hear me out. Ready? I'm going to use the 1 from the p first. So I'm going to do 1 over 1, and then I'm going to do 1 over 2. So I'm taking the first p value and putting it over each of the q values. And now I can't use that one anymore. Okay, so then I'm also going to do 2 over 1, and then 2 over 2. Right, notice where the numbers are coming from, right? They're color-coded, right? I'm doing the purple 2 from the p list, the 8 list, and I'm dividing it by each of the factors of 2. Right, and then I'm just going to keep continuing here. Right, so now I'm going to do 4 in the top, and I'm going to divide 4 by 1 and 2. And then we're going to do it one more time. So now, oops, got to cross off that 4. I'm going to divide 8 by 1 and 2. Okay, so now I want to go through and simplify because I don't want to have any repeats. So if I look at the first one, plus and minus, so 1 over 1 is 1, so I'm going to get positive and negative 1, and then 1 over 2 is 1/2. Okay, so I've done this row. Okay, 2 over 1 is 2, so plus and minus 2 is an option. And then I get to plus and minus 2 over 2. Well, this is equal to 1, and I've already used that, so that's a duplicate. I don't need to write it again. So then I'm going to get 4 over 1, which is 4. I'm going to move this list over, give myself a little bit more space. And then 4 over 2, right, that's equal to 2, and I've already listed that, so that's also a duplicate. I'm done with this row. And then 8 over 1 is 8, and 8 over 2 is 4, so that's another duplicate, so I don't need to write that again. So these are all of my possible rational roots.